Spring physics is such a powerful tool in the game developer's toolbox. They can bring even the most mundane graphics to life, making them feel dynamic, interesting, and juicy. From juicy player movement to responsive environment and even UI animations, Spring physics can add smooth motion and fluidity to any game. You can apply them to parameters like skew, scale, and rotation to make your game feel amazing to play. And the best part? They're incredibly easy to implement. Hi, my name's Jaqued, and 20 months ago I quit my day job to develop my dream game, Tyto. Now I want to share with you some of the lessons I've learned along the way. On Tyto, I use Spring physics for almost every type of motion. I'm speaking about the treetops, the tree branches, the floating logs, the mushrooms and grass on the ground, and even the player movement itself is based on Spring physics. I'm gonna demonstrate these principles in the Godot engine because that's the engine I work with, but these principles are relevant to every type of game engine. So let's start making our first Spring physics demonstration. First of all, I've created a really simple scene where the sprite changes its skew based on the mouse position. If I'm pressing the mouse button, it will change its skew. If I'm releasing the mouse button, nothing will happen. It's really simple. I will go over it really quickly, but it's not the important part of the tutorial. So what I'm doing right here, I have two variables, the start position and the follow mouse boolean. And whenever there's an input event, I check if it's an input event of a mouse button press or release. If it's a pressing of a button, I will change the boolean of follow mouse to true. If not, I will set the follow mouse to false. So far, really simple. If I'm pressing the mouse, it will be true. If I'm not pressing the mouse, it will be false. And then whenever I start the scene, I will just set the start position variable to the global position of the scene. And then in the process function, which means I'm doing this every frame of the game, I'm checking if I'm supposed to follow mouse, which means the mouse button is pressed, and then I'll check the distance between the mouse global position and the sprite global position. I'll check the distance between them on the x-axis, and then because I want skew not to be like in too crazy amounts, I'll just divide it by 500, and that's it. Notice the return command here, which means if I'm pressing the mouse button, I won't continue to the code we're gonna write here. So let's create a function, and we'll call it Spring. And I want to call this function every frame of the game unless the mouse button is pressed. Before we write the Spring function, we need to declare a few variables first. So these variables are the spring rigidness, and I like it to be like 0.1, and then the spring damping, and usually I set it to twice as much as the spring rigidness, but you can play with these values later. And then we need the spring velocity, which I'll set to 0. And then we need the spring destination, which I'll set to 0 as well. Now I want to take these four variables and make a spring function that affects the skew of the sprite. So if I'll change the skew of the sprite and then I'll leave the mouse button, I want the sprite to go towards the destination, which is currently 0. But instead of just going directly to it, I want it to overshoot it and then go back and then go back and then go back. Now, the more rigid our spring is, the more energy it will have towards the destination. And the more damping we're gonna have, the more energy we're going to lose. So now I want to create a function that calculates all of those. And it's really simple. Let's write the Spring function code. First of all, let's declare a variable, which is going to be the distance to destination. And it's going to be equal to the current amount of skew minus the wanted amount of skew, which is the spring destination. I'll remind you that currently the spring destination is 0 because we want the spring to go towards 0 skew. You get the idea. Now let's declare another variable, which is going to be the loss of energy in each frame. Now we calculate the loss of energy based off the spring damping that we declared before. So I take the spring damping, but I want to also calculate the fact that the faster the spring goes, the more loss of energy we're gonna have, that we are gonna lose more energy the faster we go. I think this is how it works in physics. I'm not a physicist, so if you are a physicist and I'm completely wrong, correct me in the comments. But I know it's gonna work, so I'll just multiply it by the spring velocity. So the bigger the spring velocity, the bigger the loss of energy. And now we have the distance, destination, and loss, and we can implement Hooke's law. Now, Hooke's law is an actual law in physics that tells us how springs behave. And the way it works, we calculate the force that's applied to the spring in every frame. So we take the force, and the force is equal to minus spring rigidness, and we multiply it by distance to destination, and then we subtract the loss. And that's the important part, we do two simple but crucial things. We take the spring velocity and we add the force to it. We don't set the spring velocity to force, we add it. And then we do the same thing to the skew, to the parameter we want to change. We add the spring velocity to it. So we don't set any variable, we just take the spring velocity and add it to the skew, and we take the force and add it to the spring velocity. All right, let's see if it works. Yeah, that looks really, really good. And I think even just this small project is so fun to mess around with. I mean, look at it. I can stare at it all day without any game involved, just doing this. It's so fun. Now let's say that instead of changing the skew, I want to change the scale of the sprite, or to be more specific, the X value of the scale. Now it's a bit more tricky, but still very simple. So I changed the scene a little bit to have a node I'll call a squisher, and instead of writing the code for the sprite, I'm writing the code for the squisher node, because I want to be able to change the scale of the sprite to make it bigger or smaller, however I want, but the springiness, we apply the change in scale to the squisher node, and I want the scale destination to be 1 by 1. So it doesn't matter what's the scale of the sprite, the scale of the squisher will be 1 by 1. I hope it's clear. Let's move on. Now we need to make a few adjustments to our code. First of all, I don't want to change the skew based on the mouse position, because I want to change the scale, or as I said before, the X value of the scale. So if I'll do this, when the mouse will be at the middle of the screen, the scale will be 0. And that's not what I want. I want it to be 1 plus the amount. So if I'll take the mouse to one side, it will get bigger, and the other side, it will get smaller. Let's see if it works. Up, up. Yeah, that's exactly what I wanted. Now I want to change the spring destination, because right now it's going towards 0, and I want it to go towards 1, because that's the default value that we have here. If it will go towards 0, it will just vanish. So it will go towards 1, and instead of changing the skew, I will change the scale.x in both cases, which means I'm changing the X value of the scale, and that's it. Now it's going to work. And yeah, that looks actually really good, but I can make it look even better. Currently, we only change the X-axis of the scale, and I also want to change the Y-axis. So the boring thing to do would be every time I change the X-axis, I also just set the Y-axis to the exact same amount, and then it will get bigger and smaller on both axes at the same time, and it's still kind of cool, but I have something way cooler to do. So yeah, that's cool. We can flip it and it will flip back. Yeah, I know. But what I really want to do is to make it squish and stretch. And the way to do it is to take the y value of the scale and set it to 2 minus scale x. So if scale x, the x value is 1, the y value will be 1 as well. So they're all going towards the center at the exact same way. But the more the x value gets bigger, the y value gets smaller. So that gives us the squishiness feel. And it looks like this. And that is so satisfying. I mean, look at it go. Of course, we can do the exact same thing with the position of the sprite. It's a bit more complicated, but still very simple. We just need to tweak the code a little bit. So first of all, let's simplify this part of the code. We'll just set the global position of the sprite to the global mouse position. And now when I'll press the mouse button, it will just follow the mouse global position like this. And if I'll release the mouse button, it won't. But I want it to go towards the center. So I need to change the sprite destination to a vector, to a position, which is going to be 0 in this case. And the velocity is going to be a vector as well, because it's a velocity of a position, which means it has to have an X and a Y value. And now let's go here, and instead of scale X, I'm going to put the global position minus spring destination and the global position plus the spring velocity. And that's it. Now it will go towards 0, 0, which is not exactly what I wanted because I wanted it to go to the center. So let's just adjust that. Remember that when we start the scene, we have the start position. So let's set the spring destination to the start position. So if I will start the scene in the middle, it will go towards the middle. Yeah, and that's super cool in my opinion. Now you got the tool of spring physics, but the way you're gonna use this tool depends on you and your creativity. But I just want to give you a few examples of how I use this tool in my project, demonstrated here in this minimalistic project. So first of all, I want my character to feel bouncy and squishy. So the way I'm doing it is my spring destination affects the scale, and the Y axis of the scale is 2 minus the scale X like we did before. But I'm setting the spring destination according to the sprite's velocity. So then when the velocity stops, the scale takes a while until it stops as well, because it's spring physics. So if you want to see the script, that's the important part. The squish target equals to 1 minus velocity.y, and I divide it by a lot so it won't be like extreme. And that's it. Here you can see the script that we are familiar with, which is exactly what we did before. And yeah, I think it looks really good. Another thing I did in my project was the bending tree branch. Now, what's happening here is, first of all, I have an area, and when the player is inside that area, the branch checks if the player is on floor, and if the player is on floor, it will change the rotation amount, or more accurately, the rotation destination based on the player position. If it's closer to the base of the branch, it will be very small. If it's further away, it will be bigger. And I can set the maximum bend value here on one of the parameters. Now, the code here is not very complicated. I just take the distance between the player's position and the base of the branch. Then I divide it by 500, which is the length of the branch, to have a variable that's between 0 and 1. And then I change the rotation destination according to the value between 0 and 1, the percentage, and I multiply it by the bend value that I can change here. Now, this is the important part. The rotation destination is not the rotation of the branch, that's the spring destination. And then later I can change the rotation degrees using spring physics. So this is what gives it the bouncy and bendy feeling. Now, it is important to state that here we're talking about like physics collisions, which is a bit more complicated. And if you'll just do what I did here, it will bounce a lot and be very janky and jittery, and you don't want that. So in my game Tyto, whenever the player is standing on a spring, I have a code that sticks it to the spring so it won't bounce around. So the last thing I want to show is the floating platform, which is really simple to do and really, really satisfying to play with. So it looks really complicated, but it's actually just 2 springs. So let me demonstrate. If I'll just cancel the movement of the platform itself, and I'll show you the springs, we have 2 springs, and they also, exactly like we did with the branch, they change their position according to the player's position on the platform. And then the only thing I need to do is to set the platform between the 2 points. I set the rotation and the position between the 2 points. Let's look at it. And that's that. The code here, again, is pretty simple and very similar to what we've seen before. We calculate the distance between the player and the base of the platform, but in this case, you can see that the base is at the center of the platform instead of at the side. So now we have positive or negative distance, and we have 2 springs. So I add the percents to one of them and I subtract the percents from the other. So then we have like opposite direction, and the sync destination affects the y-axis of the position. And then I set the rotation of the platform to the angle between the first spring and the second spring, and I set the position of the platform between the position of one spring and the other, and then we have this floaty feeling on the platform. Thank you guys so much for watching this video. I hope it was helpful, and if you have any questions at all, feel free to write them down at the comment section and I will answer each and every one of those. By the way, Tyto is available to wishlist on Steam, so if you think Tyto looks cool or you just want to support this channel, feel free to wishlist Tyto on Steam. Thanks again for supporting this channel. Goodbye.